In this film, you will become acquainted with a modern and economical interlocking nail system for the treatment of femur, tibia, and humerus long bone fractures. The wide range of implants intended for the femur can be applied for treating pertrochanteric, shaft, and distal shaft fractures, as well as condyle fractures. Similarly, the treatment of shaft fractures of the tibia and humerus. With the humerus, surgical treatment can be carried out both in an ascending or a descending manner. The implants are produced from grades of implant steel according to DIN ISO 5832-1. All treatments can be performed with a basic set of instruments together with a few additional instruments for all nail variants and indications. For the user, that means simple handling of the instrument set, minimal storage requirements, maximum flexibility in the choice of treatment, customized in each case for the site of operation. This also means a reduction of radiation exposure for the patient and the surgeon due to the fewer images taken with X-ray control during distal interlocking in the treatment of the femur and tibia when the unique distal aiming device is employed. In the examples presented, you will also become acquainted with the main applications of a modern battery-driven motor system.
Meine Damen und Herren, ich möchte Sie hiermit begrüßen zur Teilnahme an unserem
Ladies and gentlemen, I would like to welcome you warmly as participants in our workshop being run over the next few days for our medullary nail and motor systems. We have made appropriate arrangements and produced models that should provide you with an insight into what we shall accomplish with the implants that we use for the individual surgical indications. In this training video, we would like to present the interlocking nail and motor systems that are the subject of our workshop. Its contents includes all applications that the interlocking nail system can be used for with humerus, femur, and tibia indications. On a step-by-step basis, you will become familiar with all the instruments associated with the implants and the components of the motor system, as well as the handling of such instrumentation.
In Verbindung mit Implantaten und den Komponenten des Motorensystems im Detail kennenlernen.
Our femur system consists of a standard drilled femur interlocking nail and a femur interlocking nail without drilling of the medullary cavity, and the multifunctional nail system. All the nails can be used for both the left and right femur. All the nails can be interlocked antegrade, and the multifunctional nail can also be interlocked retrograde. The multifunctional nail system, or MFN for short, consists of a short version for femoral neck and pertrochanteric fractures, and two long versions for supplementary treatment of shaft fractures in the femur. The multifunctional nail can be proximally interlocked either statically antegrade or retrograde. Here you can see an example of how the MFN nail is assembled. Connect the components of the proximal aiming device for retrograde distal interlocking with the short MFN. In this example, you can see the clamping of the nail for a left femur bone. The curve of the nail must point downwards. As usual, with the right side clamping, the nail is rotated by 180 degrees on the proximal aiming device. For a right femur, the hand grip must be removed from the proximal aiming device after the proximal interlocking has been completed to prepare for the distal interlock. When the hand grip has been removed, remove the aiming arm retrograded, rotate it 180 degrees, replace it, and screw the hand grip back on. The aiming device is now ready for distal interlock. In the following example, the setting for MFN treatment has been prepared again for a left femur. The insertion point is set and the medullary canal is opened centrally under X-ray control. Introduce the 3 mm guide wire with the hand grip and the Jacob's chuck. Advance the wire in stages until the end of the medullary canal is reached. This process is performed under X-ray control. This procedure applies only to pertrochanteric treatments with the short MFN nail. With the long nail versions for treating shaft fractures, introduction of the guide wire is performed in the same way as for U, R, or standard nails for drilled medullary cavity. Introduce the 15.0 mm cannulated reamer via the guide wire and cut in a clockwise direction of rotation. When the reaming process has been completed, the reamer is then removed also with clockwise rotation. Reduce the fracture manually by extension and lever action on the limb. This process is performed under X-ray control. After the reduction has been assured, nail insertion is performed. Now take the proximal aiming device with the attached MFN nail and thread the nail in via the 3 mm guide wire. Nail insertion must be performed without impacting, i.e., the nail must be able to be pushed into the medullary canal. This procedure only applies to treatments involving the short MFN nail. When the insertion is complete, remove the 3 mm guide wire. To bring about retrograde interlocking, slide the green drill sleeve over the 2.1 mm silver drill sleeve. This component is then introduced into the distal aperture of the proximal aiming device. Advance the green silver drill sleeves until the cortical bone is reached, and clamp the green drill sleeve in this position. Then thread the 1.8 mm drill wire into the silver drill sleeve and start screwing in the drill wire. Now AP as well as LM imaging is performed to determine the position of the retrograde proximal interlocking as well as the antiversion angle. When the position of the sliding screws and the antiversion angle have been assured, the procedure can be continued. If the drill wire is not correctly positioned, it must be removed and repositioned in a correct manner, as can be seen here. The drill wire must be introduced under X-ray control. Now lay the screw depth gauge with its grooves at the drill wire flush against the silver drill sleeve and read off the measured length according to the calibration. Determine the real length of the screw by subtracting 10 mm from the measured length. When this has been done, select the appropriate sliding screw. After this procedure, remove the silver drill sleeve and replace it with the blue drill sleeve. Now drill with the 4.8 mm cannulated drill in a clockwise direction. Drilling is continued until the calibration of the measured length is flush with the collar of the blue drill sleeve. As usual, this procedure is performed under X-ray control. After the drill depth has been achieved, remove first the drill while rotating it clockwise and then the blue drill sleeve. Using the 6.4 mm reamer, ream the lateral cortical bone until the reamer strikes the collar of the green drill sleeve. After the required cutting depth is reached, the bit can be removed. Note, with the long version of the MFN nail with a proximal shaft diameter of 13 mm for narrow medullary canals, the lateral cutting step is omitted. In such cases, 5.0 mm sliding screws are used and a 4.0 mm cannulated drill is used for pre-drilling. Place the measured sliding screw onto the 5.0 mm hexagonal T-grip screwdriver. Introduce the sliding screw into the green drill sleeve via the guide wire and advance it until it strikes the pre-drilled drill hole. Then start screwing in the sliding screw under X-ray control until the screwdriver marking is flush with the collar of the green drill sleeve. After removal of the screwdriver, LM and AP imaging is performed to complete the documentation. Now remove the 1.8 mm drill wire with anti-clockwise rotation. Remove the drill wire and then the green drill sleeve. With the second retrograde interlocking, the step involving the drill wire is omitted. Insert the gold drill sleeve over the green drill sleeve. Take the 4.0 mm trocar together with the hand grip and the Jacob's chuck and push the gold and green drill sleeves over the trocar. The trocar, green, and gold drill sleeves are introduced through the proximal aperture of the aiming device and advanced until the cortical bone is reached. The green drill sleeve is then clamped in this position. Center the cortical bone with the trocar and then remove the trocar in the gold drill sleeve. Now slide the blue drill sleeve inside the green drill sleeve. Using the 4.8 mm non-cannulated drill inserted inside the blue drill sleeve, start the drilling process in the same way that the distal process was performed. The drilling depth, however, is reduced automatically by 10 mm. This process is performed under X-ray control. Now start cutting the lateral cortical bone. Using the 6.4 mm reamer, ream until the reamer strikes the collar of the green drill sleeve. When the required cutting depth has been reached, remove the reamer. Note, this second proximal sliding screw is exactly 10 mm shorter than the distally adjacent sliding screw, since the drilling depth is always reduced automatically by 10 mm. After you have selected the screw, proceed in the same way for the first distal sliding screw. The proximal interlocking is complete. Insert the gold drill sleeve over the green drill sleeve. Take the 4.0 mm choker together with the handpiece and the Jacob's chuck and slide the green and gold drill sleeves over the choker. The choker and the green and gold drill sleeves are introduced into the proximal of the two distal openings of the aiming device and advanced until the cortical bone is reached. When centering the cortical bone, the green drill sleeve must be manually held in position. This manual holding must also continue during the next working steps. When the centering has been completed, remove the choker. Replace it with a non-cannulated 4.0 mm drill and drill until the opposing cortical bone is drilled through. After this, insert the depth gauge so far that it can be hooked behind the opposing cortical bone. Read off the screw length at the collar of the green drill sleeve. Choose the appropriate screw length and screw in the 5.0 mm screw through the green drill sleeve using the 3.5 mm hexagonal screwdriver until the marking of the screwdriver is flush with the collar of the green drill sleeve. Then remove the screwdriver and the green drill sleeve. The first distal interlocking is now complete. The second distal interlocking is performed in the same way. A final AP and LM imaging should then be performed for documenting the distal interlocking. When the distal interlocking is complete, place the universal socket wrench on the adaptation screw of the aiming device and in this way release the connection to the nail. Now take the 5.0 mm hexagonal screwdriver with the 15 mm screw plug and insert this into the proximal end of the nail. The interlocking is now complete and the incisions can be closed in the conventional manner.